have some time at the end for questions. So if you see at the bottom of the Crowdcast screen where it says ask a question, you can ask your own questions in there and see the questions of other people and upvote the questions that most interest you. Let's start by having everyone introduce themselves and give a quick overview of the project they're working on. Starting with you, Jesse.
Thanks, Phil, and thanks for having us here. Hi, everybody. I'm Jesse Morris. I'm the CEO of the Energy Web Foundation. I've been with the project since early days, since 2016. And also, it's great to be here with Stedin and Elia Group, who were, correct me if I'm wrong, some of the first companies that helped get this whole thing off the ground. So it's awesome to be here 5 years later, which is ancient time in crypto times, talking about how we're, all of us, Energy Web as a foundation, but also our partners, using Web3 technology to accelerate the energy transition, to basically help digitize systems around the world, to accelerate decarbonization. And maybe that should be my brief introductory comment. For those of you who are not kind of familiar with what Energy Web Foundation does or the companies that we work with, it's very different than a lot of other crypto projects. We are focused on using blockchain and other decentralized technologies to actually transform the way that we run energy markets. We help companies like Stedin, like Elia Group, actually build enterprise-grade solutions on top of things like the Energy Web chain and other technologies, to basically, again, transform the way we run energy markets. Kai and Arjen will speak about their applications, which gives much more specific flavor about how all of this works. But just know that Energy Web's DNA is all about using Web3 technologies to fully decarbonize the world's energy systems. So excited to be here to talk about it.
Thanks, Jesse. Kai?
Sure. Hi, everyone. Again, thanks, Phil, for having me in this call. I'm really excited to discuss about blockchain-related topics in the energy sector. This is what I'm working on since 2 years. I'm innovation manager at Elia Group. Elia Group is a transmission system operator. So we are transporting electricity on the high voltage transmission lines, so the big power lines that you see when you run on the highway. And our task is to build this infrastructure and to operate it and to develop also the energy market further. And we are facing a tremendous change in how the system is operated or will be operated in the future because of several reasons that I'm happy to explain later. And what I'm doing with the Energy Web Foundation and also in the DLT lab that I'm leading at Elia Group is to basically run use cases and proof of concepts to test blockchain-related technology and to explore how we can better integrate, especially decentralized devices like electric vehicles, heat pumps, or other flexibility services into the electricity grid. So this is the mission that I'm working on, and looking forward to the discussion.
Thanks a lot. Arjen, you want to introduce yourself and your project?
Sure. Thanks, Phil, for having me. Arjen Zuijderduijn. It's a difficult Dutch name, last name. I work for the Dutch DSO Stedin, where we operate, I think, the third largest part of Netherlands, being The Hague, Rotterdam, Utrecht. And as of this year, also the Zeeland province. I work in an innovation department where we face similar challenges as Kai elaborated upon, is a highly electrifying grid. Today, it's even more relevant with everything going on the gas side. And that means that everything we do on managing our grid, the top to bottom in the past, is a bit outdated. We see that going bottom up encourages us to think differently and to do different projects and to develop ourselves even further. I think that's interesting in our innovation department, but also scaling up to the business. And I believe, looking at the blockchain project we're at the verge of interacting with the business, our customers, the prosumers who produce and consume, or both, or just one of them. And looking forward to the discussion today. Back to you, Phil.
Thank you so much, everyone, for doing the introduction. And I just want to go over some of the topics we're going to be discussing today. So we're going to talk about how Web 3.0 can improve energy efficiency. We're going to be talking about some use cases in development and this new technology and digitization of energy. We're going to go into smart meters and decentralized grid with better security, and how enterprises are getting involved in this as well, and how Polkadot's relay chain and parachains and maybe another chain will play a big role in this process. So starting with a question for Jesse with Energy Web Foundation is, you've been in this space quite a long time, as you mentioned. It's a long time in blockchain years. And Energy Web has been early in this game as getting blockchain involved in the energy sector, partnering with some big corporations and enterprises. But how have you seen blockchain evolving as an application in the energy industry over the past few years?
That's a great question. I think I was joking with a friend the other day. Over the past 5 years, since we've been experimenting with this, we found several hundred ways to not use a blockchain in the energy sector, and we found a few really good ways to use it. That would be my simple answer. And that's how innovation happens. I mean, I can remember being in a room with the three of us from the Energy Web community, sitting around a table, coming up with all these kinds of use cases. Remember when everybody was talking about peer-to-peer stuff back in the day, and how blockchain was going to radically transform all of these microgrids and blah, 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 blah. Well, it turned out 99% of that was marketing. And what have we learned since then is we've actually found some really, really powerful ways to use blockchain in combination with other technologies. That would be my kind of primary point I'd put out to this group, is that our ecosystem and our technology stack isn't just a pure blockchain capital B thing. It's about using blockchain for what it's good at, which is establishing trust with things in the real world. And we do that by pairing it with something that I'm sure Kai and Arjen will talk about, decentralized identifiers. So the standard for self-sovereign identity, which we'll get into a little bit later. That's really what our entire tech stack is focused on. And you asked, well, how has that kind of changed over the past couple of years? Our stack evolved from a blockchain only thing to now a full stack that uses different open source standards, that uses blockchains. As you said, Phil, we'll soon be using multiple blockchains. And so that's the big thing we've learned, is that in our enterprise ecosystem, we found that the killer use case for blockchain in the energy sector is really about pairing it with decentralized identifiers, the standard for identity, to make it cyber secure, low cost, and easy to get things like smart meters, electric vehicles, wind turbines, solar systems, any of those things, to get them digitized and able to share information with different companies. That's our definition of Web3. It's not about, printing carbon NFTs. It's not about doing a lot of the other stuff that you probably see in the Web3 space right now. That, again, I would say is mostly marketing, about, taking a database that has a bunch of information about certificates and then putting them on a blockchain. Woohoo! That's not what we do. The projects that we're going to talk about on this call are about real world use case, using Web3 technology to make it possible for multiple businesses with their own IT systems to exchange data, all the way down to things like smart meters. Sorry, I'm rambling a bit, but again, the big thing we've kind of discovered with our ecosystem, I would say, and Kai and Arjen, I'm curious to hear what you say, is this pairing of blockchain with decentralized identifiers is really powerful for enterprises.
Yeah, that's a great answer. And there is a lot of different use cases. I've been in this space for a while as well, and we've seen the hype around many different use cases happen. And when you bring that to enterprises, which you're all working with, I'm sure they see through a lot of that as marketing and useless for them. But let's just get right into it. You heavily focused on decentralized identifiers, and Kai, I'd like to direct this question to you. Is that, we have so many different types of energy sources and things that are drawing energy. How exactly is blockchain enabling the decentralized identifiers for the system, and why is that so important for energy?
Yeah, so I think maybe we have to also start with what is happening right now in the energy sector and why this technology is important in the first place. And I think what's happening is that we see, firstly, a decarbonization. So we have a lot of, so the fossil fuel power plants are replaced by renewables. And this results into a paradigm shift. So in the past, the power plants were producing electricity to serve the demand. And now we have to switch around. So we have to adapt our demand based on the supply of renewables. The second thing is happening. What's happening is we are having a much more decentralized system. So we have many more power plants, can be wind turbines, can be rooftop PV power plants that are installed on your home roof, and we have a switch from consumers to prosumers. So people start producing electricity and putting this electricity back in the grid. And the third thing is digitization. So all of these devices that we integrate into the energy system, they can communicate over the internet. And what we have to do now is to put all this together in one system and to make this efficiently work together. And therefore, we need information that we can trust. And this is where SSI and DIDs and verifiable credential come into place. And SSI is basically a concept that allows you to manage your identity. And that can be applied to individuals, so people, but it can also be applied to machines. So you can create machine identities. And the interesting thing about SSI is that you don't need necessarily an authority that manages these identities. And you as a user or a device itself can basically decide what kind of information it wants to disclose. And therefore, there are two standards that are relevant. One is the standard is DID, so Decentralized Identifier, which is a unique identifier that you use to navigate and to identify yourself in the internet. And every device or every entity could be equipped with a DID. And this allows then the second standard, which is a verifiable credential, to exchange certain information and describe characteristics of machines or people or organizations in a way that is cryptographically secure, is verifiable through machines, and allows this minimum and selective disclosure. So we can verify information independently without going back to a central authority to ask if certain information is correct. And this is enabling a new way of how we can integrate also with different sectors. So we see now that mobility sectors, for example, providing a huge source of flexibility that we need in the grid. So all electric vehicles, they are batteries on wheels, and we have to integrate them. But we also have to get information about technical specification. Who is the owner of that car? What does the owner want? All these information, they are stored somewhere, and we can either put this in a huge database, and one entity is owning it, and no one wants that, or we make it in a more decentralized way, and we use SSI to get to this information and put the consumer actually in the center to decide what kind of information she wants to disclose with whom.
Sorry, Arjen, is there anything you wanted to add to that, or should I get to the next question?
In relation to the DIDs, Phil, we have done it a bit the other way around from a DSO perspective. Not saying that Kai's solution is we're getting there. The thing is that we have had our enterprise architect who was burdened with the task of creating our IoT infrastructure, the architecture for all our sensors in the grid, enabling all this decentral activity to be suiting us for a safe environment. The main risk for IoT, in his opinion, was security. What he has done is, and this ties into what Jesse just mentioned, is that without all the marketing, just finding a solution for the IoT security, he put out a Google Scholar alert. It's a tip for everybody. If you want the solution, go find these kind of like really nice ways to find solutions. And what he found was not one academic paper, but over a time span of 2-3 years, 16 academic papers from all around the world, underwriting the use of blockchain in relation to security, and also proving the value in relation to security, cybersecurity, that is. He asked us, we do something with blockchain, right, in relation to indeed the energy communities, the peer-to-peer trading, etc. Are we open to look into this, the security part of the IoT assets? Because we're installing, I think, over 4 million sensors in our grid, being smart meters, being mid-voltage meters, being individual sensors, being high-voltage meters, etc. That's more than 1.7 sensors per customer in the end. To really get the grasp of what's happening in our grid on power quality, on capacity, etc. And what we've done is we've looked into the DID solution with Energy Web. We have created 8 steps, I won't mention all 8, to get to a full-scale system. And the first thing is just get started, get a fundament, get a basis. Just onboard anything, like Kai mentioned. You can onboard anything you want. It doesn't matter. You can give every item you have, you can give it an identity. And we have created this fundament, first step, where we can really create a level of level of trust around any asset. And I think for us, it's really a real interesting and learning journey. And the next step is to scale it up in the business. And I will mention that later, but I think it's good to understand that not only to interact with third parties like electric vehicles, it's also important to have it in your own IoT infrastructure. It can really help raising the level of security and trust that's needed to interact.
Yeah, great. This is one of the reasons I was excited about this Web3 talks, because we're touching on a lot of things that deal with Web3 that haven't really had their kind of time of day yet, such as decentralized identifiers and I just lost it, but something else. But yeah, it's really exciting to see. And I wanted to get a sense of, we have these great speakers here. How are you exactly working with one another to come up with your solutions?
I'm happy to start. What's really interesting is that we all built this together. And I don't even mean Energy Web Foundation. So the same infrastructure around decentralized identifiers is supporting both of the use cases that we've started to talk into. So even though Stedin, Arjen's company, is focused on this internal cybersecurity use case, as I would call it. So basically, you have an enterprise that's deploying mission critical IoT devices across its network. How do you roll out a secure infrastructure for managing those things, registering them, tracking them, et cetera? Decentralized identifiers anchored by the Energy Web chain. In Kai's world, it's speaking about the same infrastructure. So we're using decentralized identifiers, verifiable credentials. So everything in the back end is the same, but different business processes. It's being applied to EV chargers, people, and other assets in the energy sector that are owned by other companies, right? So we only got there, Stedin Ely Group Energy Web, by jointly working with grid operators from around the world to figure out what is blockchain good for, right? So I'd say at the highest level, that's how we work together. Like, we didn't come up with this in a vacuum. We, business analysts from different companies, were basically sharing requirements, and we said, hey, let's build some open source tech that can do this anywhere in the world. And we don't have we could only fit a couple people on this panel, right? But if we flip around to the other side of the globe where it's dark right now, in Australia, same tech is being used to support a nationwide rollout. That's a bit of a hybrid between the Stedin use case and the Ely use case, with the same underlying technology. And I know there's a bunch of Web3 crypto folks on this line, but if you put on an energy hat, that is unprecedented to have utilities from around the world collaborating and jointly building software. That's crazy. So anyway, we kind of built it together.
That's cool. It really is one of the main uses of blockchain, is to get parties that don't necessarily trust each other to be able to trust the system in which they can interact. And speaking of which, when we often talk about user adoption in these Web3 talks or any Web3 presentation or conference, it's often directed at the consumer. And everyone already has adopted electricity in our world, at least, and the kind of user adoption when we're talking about is about getting these companies on board, the energy providers. So how have they come to you, or have you like noticed this in the space, in the energy space, that this is a need that only blockchain can solve, or is this something that they were looking for? And how hard is it to get them to adopt this, like to understand the actual value behind this that you're providing? Anyone can answer.
I kick it to Arjen or Kai. All I'd say is that's most of the battle. Is the tech is there if it's not fully developed yet, but like it's pretty much there. Really understanding business value of a Web3 approach versus a Web2 approach, that's a big communication challenge, and indeed where a lot of our energy goes. Arjen, I don't know what you think.
Whilst looking at our roadmap of the 8 steps, the second step is indeed collaborating with our big telecom provider, the IoT solution provider. And the thing that happened, and that's what our C-level people are actually really fond of, is that without the direct support from Stedin, paying their man-hour bills and making sure that we actively support this step, we said, okay, we want to focus first on the first step, the fundamentals of onboarding. Second step is going into the eSIM and the SIM card and adding that to the equation, really raising the level of security in the IoT system. What this telecom provider has done is they said, okay, we won't wait for Stedin to finish their first part. We want to make sure that we're on board, because IoT security is not a risk for Stedin only. It's a wider risk than that for all IoT relevant parties, especially for the IoT solution providers. And they have connected intrinsically with Energy Web, and they've built a standard, an open source standard. We didn't touch that really yet, the open source part of this. And they've onboarded it into their business development themselves. For me, that's a major eye-opener in a way that the industry is now getting more and more ready into looking to these kind of solutions. My effort into developing this second level is now lowered from maybe 100% to back to 20%, just make it specific for Stedin. And this for us was really a moment of, we're not the only ones looking into this kind of solutions. There are more parties looking into this, and these are parties who are globally connected.
Kai, how has it been working with companies trying to, or maybe looking at adopting this?
Yeah, so I think that we have still quite a way to go. So it's what we as a grid operator, we are a regulated company, and I think we have our goal is to create a system where everyone has a non-discriminatory access to the electricity grid. So we want to provide a solution or want to create an equal playing field for everyone. And I think this is why we also think that this technology is very interesting. We see that especially outside, and this is also what Arjen mentioned, that other industries are starting also to adopt this technology, and especially the e-mobility sector. So if we look into autonomous vehicle, this concept of SSI and self-sovereign identity is adopted, or they are looking into this because it creates possibility of new use cases. And this is where we are trying to get in and say, look, there's also the energy sector that is really benefiting from an easier access of decentralized assets. So what we're trying to do is we are building right now, and this is an ongoing thing, is we set up building blocks that companies can use. So that is, for example, an SSI server, or we also want to have a very simple wallet. And that is also in line with the principles of Energy Web, that we provide this open source to any partners that want to join with us. And then we can demonstrate, because I think there is still a lot of explanation to be done in order to explain why, and we also have to prove it, that this is more beneficial than another system. But what we try to do is we set up basically all the building blocks that companies need to exchange between each other in a Web3 way, to create verifiable credential types, so to describe certain assets, and then to see how would this affect the real world. So we try to get real sandbox use cases and say, now this is a setup of a household with an electric vehicle, and how can this really help us? And I think this is what we have to demonstrate. Because the energy sector is usually is rather slow, and if we are not careful and if we are not pushing this technology, someone else comes and the regulator says, oh, okay, we use this technology and this is then fixed for the next 10 years. And then we are too late. So basically, this is, and it's ongoing. You see it also in Gaia X, for example, or Catena X, where you see that this whole topic of identity management is now happening on so many different fields, that traction is there, understanding is there. So I think now we really have to show it how and why this makes things better. But it's a complex task, because we have to. Because it's decentralized, it also requires the participation of decentralized of everyone, and you have to set up a governance framework. We have to set up roles, and it's completely different to how it was before. And this is nothing that happens alone. So we are trying to because we believe in the principle, to provide building blocks and to encourage everyone to work with us on these use cases.
Cool. Yeah. Speaking of use cases, it's kind of what I want to get into in a bit more detail. I know that Stedin is really focusing on IoT devices specifically. These devices could be smart meters, if I'm correct. I know there were some other use cases you're exploring, such as like flex bidding in energy markets and some sort of switchboard maybe. But yeah, if you want to go into that, we want to talk about use cases, because I mean, energy is a big topic and a lot of people don't really understand how this can, it takes a while to learn to understand how this can really impact you. But on a kind of a level that we're all a bit more, we feel more tangible with, how is Stedin working with IoT devices and meters and anything else to bring the use cases forward and illustrate this technology?
Yeah, good question. What we have done, we have fulfilled the burden of the European Union to provide or offer 80% of our households with a smart meter. In our case, that's over 2 million households. Besides the residential households, you have the industrial parties who already have a smart meter. And then the amount of IoT devices already increased. Looking into this collaboration with Energy Web, we've looked into 2 use cases where we've looked into, can we onboard new fresh IoT devices that are being manufactured today or tomorrow and can easily be onboarded as per factory interaction? And can we also onboard legacy assets? Because we don't want to do a do-over of the smart meter rollout anytime soon, hopefully. Knock on wood there. But we want to onboard these as well, because these are really interesting and really giving us the decentral trust layer. Then you get at the indeed, what you've mentioned correctly there is the level of the Energy Web switchboard. Where on the top layer, I foresee the mission critical assets being the mid voltage meters, which we are currently developing, and we will roll out I think 25,000 of those in coming years. And we have many difficult questions. Can we also look into the asset governance of these meters? We have several meters, we have RTU, we have a modem, we have a SIM card. Can we all link them in to this DID and can track them as per registry use case? The answer seems yes, but it's one of my 8 steps in my roadmap. Can we do the legacy onboarding again? It's one of my 8 steps in the roadmap, but for now, the hypothesis is yes, we can do it. And we're looking into field tests the coming weeks. So in the coming few weeks, I will give you a more clear answer on that. And if you look between the lines of my answer, you can see a use case on registration, uniform registration. You can see a use case on more and more uniformal backend solutions, where we have, I think, over 50 backend solutions for all types of IoT assets. And it's to be honest, a mess. And we can uniform that to a higher level, also create a higher level of quality there using this. That's, again, the hypothesis. Another one is the ease of installation. So what I've asked Energy Web, and they've responded positively, is if an installer comes to a certain area, can we install a mid-voltage meter, for example? Can we connect it to the installer, to the location, and to the characteristics of the meter? Knowing it is just a plain meter, can it shift? Can it use edge computing, etc., etc.? So is it future-proof? And that's also something that we want to do in the installing part. So really in the field, making sure that an installer only needs to verify its credentials. It's as easy as face recognition or just the press of your thumb. Installing your GPS location or verifying your GPS location and saying, I've seen 3 green lights lighting up after installation done. This seems rather no-brainer, but however, currently the installer is using the equal amount of time for installing and doing the administration on the site, making sure that our current performance is really bad in tracking back our IoT assets on mid-voltage level. Then we come into step 6 or 7 of the roadmap, where we do want to use the switchboard, where we say, okay, can we onboard prosumer assets? And we're already starting to the talks with energy communities, big companies in congested areas, where we say, okay, if we really want to trade energy and rely on that energy for congestion purposes or power quality purposes, then we need to have a level of trust. I have a solution. We can try it. It's called blockchain Energy Web. Have a look into it. And these are the first exploratory conversations that we have and that we need to have. As Kai clearly mentioned, you need to involve all level of stakeholders, from C-level to mechanics to our customers.
Yeah, Jesse, did you want to add to that? Because I know you are working a little bit on one of the projects you mentioned.
I mean, for both of these use cases, just for the audience to kind of wrap your head around all this stuff in the energy sector, they can get pretty complicated. And there's a lot of business processes. I mean, Arjen just walked through all the way from an installer going to somebody's house, installing something the way it's done right now with, did you say there's like 50 back-end IT systems for some of the existing assets that you guys are managing?
It's a mess. We're tangling our way out of it.
So
and this is one of the solutions we're looking into.
And that's not uncommon. If you talk to a grid operator, everybody's utility in their backyard, they might even not even have an IT system to track this stuff. Famously in the UK, there's some of the distribution system network operators, so the local networks, they don't even know where the wires are, right? So it's a miracle the grid works sometimes, let's put it that way. And what we're kind of talking about with all these solutions, just to simplify it, is there's this thing called Switchboard. That's a tool that makes it easy for enterprises to use decentralized identifiers to register people, assets, and organizations. And for every use case that we build in the Energy Web community, that's the starting point. Yeah. And then if I were to dramatically simplify, starting from there, there's really 2 use cases that we're focused on. Once you've registered these assets, then it's about like, what do you do with them? So on one side, it's a little bit about what Kai's company is experimenting with. It's saying, can we make it easy for a electric vehicle or a charge point to provide a service to the grid? So basically charge or don't charge your car in a specific time interval to help balance the grid, if I were to be like really simply explaining it. And that's the work that we're doing in Europe, in Australia, in California, is to just give grid operators a tool to try and interact with those assets to get them to use or not use electricity at certain times of the day. So that's one of the use cases. The other one is actually about providing proofs about electricity. So that means, let's say I have a solar system that's been given a DID, and then that solar system produces certificates that say, hey, I'm here, I am in this part of the grid, and I'm offsetting this much carbon, right? So that's a very different use case, same underlying infrastructure. But generally speaking, those are the two that we're involved with at the Energy Web community, is some flavor of those two. And actually with Kai's company, we've done kind of a mashup of one of them, which is pretty interesting. So
yeah, you guys are helping this flow really, really well. So I was just going to ask about Kai about the e-mobility use case and how Energy Web is supporting it.
Mm-hmm. So the first use case that we did was to create such a DID, so a digital passport for a vehicle. And this is a project that we've done with BMW. And we basically showed or demonstrated that we can interact with the credentials of a vehicle. So that means that we can trust information that has been issued to that specific car. We can read the verifiable credential. We can verify that this information has been issued from the OEM to that vehicle, and then in return issue a credential to that vehicle. Says we put a stamp on the car and says this one is allowed, authorized to participate in flexibility services. And then the car can go to an aggregator or to a flexibility service provider and says, look, I have this credential from Ilya. You can now onboard me in your service. I mean, this is still a future vision, but this whole exchange of information, this is working, and it's basically technical implementation. The second thing what we are working on right now is a quite practical use case, and there we look into charging of electric vehicles, and the fact that users can today not really select the energy supplier they want to use for charging their vehicle. So if you charge your electric vehicle somewhere on a parking lot outside, you are bound to the electricity supplier of that charge point operator. But you could also imagine an energy future where you want to use your electricity that your rooftop PV panel produces at the same time. And you have to create a link between your household, your car, and then link these two systems to prove I am now charging with the electricity that is produced on my rooftop solar system. And to make the bridge between the two ecosystems, mobility and power, you have to agree on an identifier. And everyone is using different standards. And by implementing SSI and verifiable credential and DIDs, we can now identify this vehicle and the owner of the vehicle that is also the owner of the PV panel that is producing granular certificates, and match this at one point. And there, I think this technology really helps, because we can create proofs. And in the specific use case that we're doing, where we want to allow this switching of energy suppliers at a charging station, we need to identify the person that is charging. We need to prove that this person has a legible energy contract with the energy supplier that this person is selecting. And the CPO, so the charge point operator, the one that is basically unlocking the charge point, has to verify the information, because otherwise he would not start that process. And you can do this again by looking up in different databases, trying to get this information together, ask the different companies for authorization, and you always need an intermediary for that. Or you do it in a way by using SSI, and you can, and the CPO, the charge point operator, can prove all the information to allow that charging process to start. So we get rid of one entity in that whole value chain, and we can directly offer much quicker services and better services for end users by having this technology. And this is one very practical example that we use to build the bridge between the power and the mobility ecosystem.
Wow, that's really, really cool. I really hope to use to power my electric car with my own home one day at a different place. That sounds really amazing. And I think that's we're already 40 minutes into this, and we have so much more to get through. But including the audience questions here. So people, make sure you ask a question. We're not going to get through them all, but try to upvote the ones that are most interesting to you so we can catch them more easily. But just before we get into audience questions, I wanted to give Jesse a chance to talk a bit about their upcoming project and consortium relay chain that they're building at Energy Web. So, and how that's going to change a lot in the future regarding energy and blockchain.
Cool. Yeah, so I can just take a minute. So for context, at the end of the year, last year, we put out an announcement that we're working directly with Parity on building something that's called the Energy Web Consortia Relay Chain. Basically since then, we've been deep in design mode on the Energy Web side with Parity, figuring out what is this thing going to look like. Most of the solutions that we work with in our ecosystem, including everything talked about today, is running on the existing Energy Web chain. And then there's also a test network associated with the Energy Web chain. I saw a few questions about that. So on that Energy Web chain, again, for those that don't know, it's an Ethereum virtual machine governed by proof of authority consensus. So Elia Group, Stedin, and about 45 other utilities from around the world and energy companies are the validator nodes on the network. There's no staking, there's no proof of work going on. It's a proof of authority network. Basically, we know who these companies are and we trust them to run the blockchain. That Ethereum virtual machine works fine for some of the basic use cases we've been talking about. It tracks tokens, obviously. You use those tokens to pay for a variety of services to power these applications. And then also, this is where the decentralized identifiers are anchored. They're actually anchored onto that Energy Web chain, which is key. Whenever you're using a decentralized identifier and verifiable credentials, they have to be tied somewhere. We use the Energy Web chain. You know, Ethereum virtual machines are kind of old school technology. They're like PlayStation 1s or 2s now. And Phil, I'm looking at you and the other folks in the kind of Substrate and Parity and Web3 Foundation and Kusama and Polkadot ecosystem. There's more tech coming to market, right? And our focus at Energy Web has been on working with companies like Stedin and Elia Group to really understand the value that Web3 technology could bring to them. So what we're doing with this consortia relay chain is we're building a new series of blockchains. And I can't say a ton about exactly what's going on with the token economics of those blockchains and stuff yet, but I can say what it is being designed around, and it's directly relevant to this conversation. So the first thing that this consortia relay chain is designed around is cybersecurity. You know, a common argument, and I'll probably botch this because there's so many Dot and Kusama folks on this line, is primary benefit of this relationship between a relay chain and parachains is really this shared security. Basically, the parachains inheriting the security from the relay chain. That's great from a crypto perspective because you're protecting those blockchains. But what do we spend most of our conversation talking about on this call? Identity. These decentralized identifiers for people, assets, and organizations. So the construct with the consortia relay chain is, imagine Elia Group has their own solution with a parachain running behind it. Imagine Stedin has their own solution or solutions with parachains running behind them. And all of those were connected to this relay chain. It's not about security of a blockchain. It's about security of those identities and the verifiable credentials. So in that sense, all of these local solutions run by utilities around the world are being secured by this relay chain that is actually checking that all of these identities and the claims around them line up. So that's the first thing we're designing this around is think about Polkadot security as it's usually talked about with the blockchain. We're applying it to identities. So using a relay chain to further secure all of the identities that are connected to these series of blockchains underneath it. The other ones are a little bit easier to explain. The second thing we're looking at is Substrate, just as a technology, is very powerful. And a lot of the things that Kai and Arjen described, we're doing off-chain. You know, what needs to be true in order for a car to be trusted to charge? We can actually jam some of that logic into Substrate itself. So that, let's say one of these local companies is running a Substrate-based solution. The nodes for that local blockchain are going to be performing some useful work that actually checks whether or not X, Y, Z is true. So long story short, we're moving the way the grid works into Substrate, which is super, super interesting. Yeah, and Phil, you said it. So you're leveraging on off-chain workers, because again, a lot of this stuff happens off-chain. With Substrate, we can move a lot of it on-chain. So that's the second area of exploration. The third one, Kai mentioned it, local governance. It's, Arjen and Kai, it's great to have you guys as validators on the global energy web chain, but you guys describe very specific regional solutions. Do you really want a utility in the other world kind of determining the governance of a local application? Of course not, right? So with more of a relay chain, parachain setup, it makes it very easy to bring on-chain governance to companies like Stedin or Ilya Group so that they can collaborate with their local partners to make decisions about the different applications, right? Pretty elegant. And finally, the last one I'd say, this is a very complicated topic, bringing Web3 technology into enterprises. The other thing we're doing with Parity is just turning it into an as-a-service model. What if spinning up one of the solutions we talked about was as easy as going into Azure, into AWS, into any other cloud service, and just spinning up one of these two energy web solutions with a parachain in the background? So that's kind of what I can say about the Consortium relay chain now. We're deep in design mode with your team. Those are the 4 parameters that we're designing around, and there'll be a lot more information coming out in the coming weeks and months on exactly what it's going to look like.
Thank you so much, Jesse. That sounds really, really exciting. Really looking forward to the next information that comes out. Yeah, you did mention something we have in Substrate. I work at Parity, just as a reminder, and we build Substrate. And one of the cool things you can do is use off-chain workers. So you don't want to put all this intense logic on-chain, but you do need a way of bringing in a real-world data from the outside in a way that's verifiable amongst all the participants, without burdening every participant with mining all this data. So off-chain workers is a great way of accomplishing that while keeping a lot of processing off-chain and keeping the main chain running that needs to do its important tasks. Okay, thank you. And this has been really, really great so far. We have over 30 questions. We're definitely not going to get through all of them, but there are a few touching on this one topic that I wanted to touch on anyway, and I'm glad everyone else is so interested in it, which is regarding clean energy. I mean, one of the questions, yeah, are these solutions you're focusing on, like, is it possible to be applied to nuclear power or coal power, or are you just focusing on solar and clean energy as well? That's the question from Bob in there. Because like we know where this is going, and I'd like all your perspectives on this, is where it's coming and going. So Arjen or Kai,
I can jump on it if you want. So of course it can be applied to also fossil fuels power plants, but the question that we want to solve is when and where do we have renewable energies in the grid, and how can we match this with the consumption, because that is the question that we have to solve. So we have to match the generation, which is fluctuating. So the wind doesn't blow constantly, sun is shining only during the day. And so we have to map this generation with the consumption side. And this is why it makes more sense to focus on, to apply this technology on renewables. And yeah, I think this whole topic of how much CO2 is used in industrial processes is also one of the biggest concern of larger corporates and companies, because they need to include CO2 as a decision criteria into their processes. So we have to basically map, ideally end to end, which device creates renewable electricity and which meter is consuming it, in order to then base these decisions on verified information and not on estimations. And this is why it makes sense to apply it on renewables.
I fully agree with Kai there. I think the main criteria that defines how this market will behave is the autonomy of the customer. Customer being a prosumer, a company, a government, who wants to keep track of their emissions, their energy usage. And for us as a grid operator, we need to facilitate that. Of course, we highly support the decarbonization. But I know that the nuclear discussion in the Netherlands is quite hefty. Regardless of that, I think the autonomy of the end user in the end is the end game of why we do this DID. We expect them to want to own their own solar power, or the ones of the neighbors, or the local, or their relatives, and that's, I think, what we are trying to enable with this in the end.
Cool. Thank you very much. We have another question from Sean. Question coming from Hawaii. Small island utility grids with high RE penetration. How can Energy Web3 integrate with grid services like the virtual power plants?
I'm happy to take that one, having done some work in Hawaii in a former life on exactly that. I've been pitching Hawaiian utilities for years to do exactly what we talked about, and I think our tech stack could unlock an immense amount of value there, is the short answer. Even in Hawaii, and just for context in the audience, Hawaii and Australia are often talked about the tip of the spear for the energy transition because they have deep renewable energy penetration, and they're island nations. So that means they can't call upon their neighbors to basically help balance the grid. So all the challenges we're talking about as it relates to managing deeply renewable systems are just exacerbated in island nations. In Hawaii, and there's the question asked about virtual power plants. A virtual power plant, that concept's very simple to explain. Picture a battery, an electric vehicle, basically any device that can use, not use, or store electricity at a certain time being networked together to act as a power plant. That's a virtual power plant. Yeah. Sounds really cool concept. I've been working on them personally for a decade. There's like very few of them in production around the world, largely because the tech is really hard. How do you get dozens of different companies manufacturing different devices, sharing information with companies like Kai and Stedin's in near real time? That challenge hasn't been solved. That's what our tech stack solves. I'd love the opportunity to come to Hawaii and work with one of the local utilities to bring out our tech stack. It's focused on solving that exact problem.
Maybe to add on the virtual power plants, did you look into Power to X, Jesse?
No.
Power to gas, power to hydrogen.
Oh, okay. Cool, yeah.
So if you want to have like momentarily balance, you can shift, of course. If you want to have daily balance, you can use electric vehicles, for example. And for seasonal balance, you can use, for example, hydrogen to store your energy. Of course, still high conversion losses there, but I think looking into the academic side of it, they're looking into this kind of solutions. Also for these really remote locations. We have some in the Netherlands, smaller scale, but same solution.
Cool. We have another question coming from an anonymous user, but it's about the switchboard you're talking about. It says, will it make it easier for everyday consumers to engage as well, or only enterprise actors?
So switchboard is, you can use it to build whatever you want. So it's the answer is yes, or jein. What is the German phrase that's sometimes used?
Jein.
Jein, thank you. Yeah. Anybody can use it. If you want to configure switchboard to make a local application for, you name it, you can use it. We just typically use it both internally as Energy Web, and I think Elia Group and Stedin have also used it to build these different solutions. So anybody can use it. In fact, there was recently a staking pool for Energy Web tokens that was opened on Energy Web chain just a few days ago. The entire verifiable credential approach that was used for that staking pool used switchboard. So we've used it for everything, whether it's staking tokens, managing credentials for enterprise access to different IT systems, you name it.
Okay, cool. What is the biggest legal barrier you face when implementing DID into energy infrastructures? I'm sure there's a lot of regulatory and legal challenges regarding the energy. Maybe Kai, or you could get into that, or anyone else who wants to take that on?
That's a difficult question. I think it's a valid one. I mean, for now we are moving. We're doing proof of concept, so we basically didn't do a full legal analysis. But I think what is critical, especially in Europe, is everything around GDPR. And I think there are a lot of initiatives ongoing, and also standards, European identity standards that that will ensure that also SSI will be GDPR compliant. But I think that there we have quite some challenges ongoing in order to really ensure and also ensure for the future that no private information is stored on chain somehow and cannot be decrypted. And yeah, maybe another challenge is how to deal with tokens in controlling in our company. So this is something which is also on the roadmap, but probably I think there also needs to happen still a lot, because that is it's more in a proof of concept stage and in an MVP stage than applied already. And I guess there a lot of legal discussions and consultations have to happen in order to implement tokens also as a payment service in day-to-day activities, or in exchange with us as a company, for example. If you want to pay grid fees or whatever in tokens, I think there, yeah, still a lot of work to do. I know how the others see it, or if you have other topics.
Similar challenge there, Kai. I think we have had many really hefty calls with Energy Web in the past about GDPR compliance in relation to the energy local energy community and the trading of it. In the end, we have built some encryption features on the chain. And in the end, I think the best way forward is indeed to keep it off-chain, the private data, to make sure you're GDPR compliant. Many innovations don't start with a legal problem. I think legal problems we will tackle along the way. So indeed, a lot of MVPs and concepts here, where we just wanted to look into how can we tackle the GDPR or the legal problems along the way. If we keep them small and contained, you can avoid it. Regarding the token management, I think we're a bit further than Kai. Just the last few months, we've made major efforts into making sure that our really really old school treasury department is onboarded, and they know how to deal with these kind of tokens. I'm being audited as we speak on this, and it seems like a rather good process. No findings yet, which we didn't expect in the beginning. We thought this is a sleeping dog. We're waking up right now, and we have big troubles there. It seems that auditing companies, governmental companies like Stedin, or government-owned companies like Stedin, they are getting used more and more by, like Energy Web Token. That is something that we're looking into. We need to look into this decentralization and the use of it, and the tokens is just a way of getting there. And this is being understood more and more, and it's making this discussion way easier than, for example, 3 years ago.
It's interesting. Maybe we have to talk, Arjen. I'm really curious on what you did.
The only thing I would add in 10 seconds, Phil, is has nothing to do with crypto. This concept of me and my electric vehicle or my solar panels or my air conditioning unit being paid to help balance the grid, just as a concept, it's very new, relatively speaking. And regulations do not allow, for example, me to be paid for the value that my devices can provide to the grid. That is a patchwork problem. It's evolving at different speed at different places around the world. And that's a big regulatory and legal thing that we have to follow.
Yeah, super interesting to hear, because it is extremely innovative what you're all working on, and I'm thankful that you joined me for the Web3 talks today. I had a really great time. I'm sure everyone here did. I'm sorry I couldn't get to more questions, but our time is up. I did want to, before we go though, I want each of you to just say how people could get in contact with you if they're interested in maybe helping out and working on your project or getting involved, or where can they get more information. please say clearly so that everyone can hear and they can find out more.
Do you guys want to go first? I can go first really simply. You can find energyweb.org. We're very active on Twitter, all the typical social media channels, but if you just go to the website, you can find all the different places to approach us. Telegram, otherwise, we're all over the place. So energyweb.org.
And for us, it's innovation.iliagroup.eu, and there you also find me and can get in contact with me, or over LinkedIn as well.
For me, it's via LinkedIn, Twitter, whatever helps. Drop me an email. I will make sure that somewhere my email contact will be shared.
We'll make sure the names and websites are in the description of the video when it's up on YouTube. All right. Well, thank you so much, and I hope everyone has a great evening. And thanks to everyone who joined and listened. On behalf of Parity, have a good night, everyone.
Thank you.
Thank you.